Okay, so let's unpack this. We often talk about medicine as this constant sort of grueling battle against inevitable decline. You know the drill, you get sick, you go to the doctor, they try to fix you. It's a very reactive cycle.
Hmm.
But what if that entire model is just, well, what if it's wrong? Or at least completely outdated?
Right. It's like the difference between frantically patching a leak in the hull of a ship versus, say, rebuilding the ship while it's still sailing. And based on the stack of research we are diving into today, we are standing at a pretty massive inflection point in human history here.
We really are. We're looking at a fundamental shift from sick care to actual health care.
Hmm.
And for the first time, and this is what really caught my attention in the reading, we have major pharmaceutical heavyweights openly using the phrase longevity drugs.
Which is wild, right?
Yeah,
That is a phrase usually reserved for, biohackers in their basements or Silicon Valley futurists, not something you usually hear from the people making the actual drugs available at your local pharmacy.
exactly. So to guide us through this new landscape, we've got a really fascinating stack of sources for this deep dive. We're looking at presentations from Andrew Adams over at Eli Lilly.
Right. He's the guy spearheading their genetic medicine and Alzheimer's research.
Yep, and we've also got Lanabeer Knudsen from Novo Nordisk, and she's basically the scientific godmother of GLP-1s, things like Ozempic and Wegovy.
And then to take things from big pharma to the absolute cutting edge of biology, we have Dr. Alessio Lana. His research on something called telomere rivers is, well, it's going to sound like sci-fi, but the data is incredibly compelling.
It really is. So our mission for this deep dive is to explore two distinct frontiers for you. First, how we're repurposing existing blockbuster drugs to protect our organs and extend life right now. And second, this radical biological discovery suggesting our immune cells can actually sort of gift youth to the rest of the body.
Yeah, it's a mix of what's available today and what might fundamentally change the human lifespan in the very near future.
So let's dive in. I want to start with this concept of sick care, because Andrew Adams from Eli Lilly used an analogy that I can't get out of my head. He talks about the house on fire.
Oh, yeah. It's a stark image, but very accurate. He says, the way we practice medicine today is literally like waiting for your house to be significantly on fire before you even think about calling the fire department.
Which is madness when you think about it.
It is,
Yeah.
because even if you manage to put the fire out, you cure the infection, you survive the heart attack, the house is still damaged.
Right.
The structure is compromised. That scorched wood is still there. Adams is arguing that the goal has to be preventing the fire from ever starting in the first place. He actually quotes that old saying, the time to repair the roof is when the sun is shining.
And that brings us directly to the GLP-1 revolution. Now, most of you listening probably know these as weight loss drugs. Semaglutide, tirzepatide. We see the headlines about celebrities shrinking. But Adams and Knudsen are basically screaming from the rooftops that weight loss is just the tip of the iceberg here. Adams actually called GLP-1s the world's first longevity drug.
That's a bold claim, but the data really backs it up. And it's not just about fitting into smaller genes. Adams shared data on tirzepatide showing that when they treated prediabetics, so people on the absolute verge of the disease, they saw a 94% reduction in the progression to type 2 diabetes.
Big 94%. That's basically stopping the disease in its tracks.
Essentially, yes, it's a firewall. But here's the statistic that made me sit up straight. In their trials, they observed a 39% reduction in all-cause mortality.
Let's pause on that for a second. All-cause mortality. That means dying from anything.
Exactly. Heart disease, stroke, metabolic issues, kidney failure. It's a profound number. If you have a drug that reduces the chance of death by nearly 40% across the board, you aren't just treating a specific condition anymore, you are extending life.
Wow.
And to understand why, we really have to look at what Lanabeer Knudsen found at Novo Nordisk. Because she explains that GLP-1 receptors aren't just sitting in your stomach or your pancreas, they are everywhere.
Yeah, she mentioned they found these receptors on specific cells in the heart, the kidney, even the liver.
Specifically the sinus node of the heart, which is what controls your heart rate. And what these drugs seem to be doing is inducing homeostasis in the inflammatory system. Meaning they are dampening inflammation across the entire body, bringing the system back to a baseline state of calm.
So it's like cooling down the whole house so a spark can't catch.
That's a great way to put it. Knudsen shared data from the SELECT trial showing a 20% reduction in cardiovascular events. We see a 24% risk reduction in kidney outcomes. But what I found most fascinating out of all of this was the liver data.
Oh, this was the fibrosis thing, right?
Yes. So for a long time, the assumption was that if your liver improved on these drugs, it was purely because you lost weight. Less fat on the body generally means less fat in the liver. But Knudsen showed proteomics data looking at the actual proteins in the blood, proving that fibrosis markers improve independently of weight loss.
So the drug is directly healing the tissue,
Ah.
even if you don't lose a pound.
It appears so. It's reversing scarring that was previously thought to be impossible to fix without just general massive weight reduction. It's protecting the organs at a cellular level. It proves that the drug is doing something structural, not just metabolic.
That really changes the narrative from diet drug to organ protection drug. But speaking of organs we desperately want to protect, let's talk about the brain. This is deeply personal for Andrew Adams, isn't it?
It is. He shared that his family has a long history of Alzheimer's. He's seen the devastation up close. And for decades now, Alzheimer's research has been a graveyard of failed drugs. Billions of dollars spent with almost nothing to show for it.
Until recently.
Yeah.
Lilly has this drug, donanemab. And the results Adams shared were, well, they offer some real tangible hope for the first time in a very long time.
They do. Donanemab targets amyloid plaque. That's that sticky gunk that builds up in the brains of Alzheimer's patients and basically strangles the neurons. In their trials, it slowed cognitive decline by 35%.
Which is significant on its own, but here's where it gets really interesting for me. He said that 47% of patients, almost half of the people in the trial, had no clinical progression at 1 year.
That's the key right there. For a disease that is entirely defined by inevitable, crushing decline, pausing it for a full year is huge. And Adams made a crucial point here, tying it back to the house on fire analogy. He says the reason we've failed so often in the past with Alzheimer's is that we intervene way too late.
He mentioned neural circuits, right? Like once they're gone.
Exactly. He said once those neural circuits degrade, you can't just rewire them. It's not like the liver where tissue can regenerate itself. Once the brain's wiring is burned out, it's gone forever. So the strategy has to be early intervention, clearing the plaque before the fire burns down the structure.
And this brings us back to GLP-1s, remarkably enough, because Knudsen pointed out that these drugs might also be protecting the brain.
This is one of the most exciting new frontiers in the space. We know GLP-1s reduce neuroinflammation, they affect the blood-brain barrier and oxidative stress, but the real-world data she shared on addiction it's just mind-blowing.
Yeah, this part was wild. They looked at people taking semaglutide and found significant drops in alcohol use disorder and even opioid overdose hospitalizations.
It affects the reward system. Knudsen and her colleagues have been studying this since 2007. It seems tea literally dampened that craving signal. And when they looked at the proteins in the blood, the proteomics again, they found links to improvements in nicotine dependence, sleep apnea, and even depression and bipolar disorder.
It's like it's turning down the volume on the noise in the brain, whether that noise is inflammation or addiction cravings.
Precisely. And that fits the longevity label perfectly. If you're reducing heart attacks, saving kidneys, potentially holding off Alzheimer's, and curbing addiction, you are fundamentally extending health span, not just lifespan. You're keeping the machine running smoothly for longer.
Okay, so that's the pharma side of the equation. That's the stuff you might be able to get from a doctor today or very soon. That's the damage control strategy. But I want to pivot to the wild frontier part of our deep dive today. We really need to talk about Dr. Alessio Lana and Telomere rivers.
I love this phrase, telomere rivers. It sounds poetic, almost like a fantasy novel, but the biology behind it is incredibly rigorous.
So set the scene for us. What exactly did Lana discover?
He started with a very simple question. How do T cells, the foot soldiers of our immune system, stay young? When they fight an infection, they have to divide rapidly. Usually, cell division shortens telomeres, which are those protective caps on the ends of our chromosomes. Short telomeres equal aging and eventually cell death.
Right, it's the aglets on the shoelace analogy. Every time you tie the shoe, the plastic tip gets a little more frayed until the shoelace falls apart.
Exactly. So logically, after fighting a massive infection, your T cells should be totally exhausted and old. Their shoelaces should be frayed. But Lana found that during an immune response, something incredible happens. The antigen-presenting cells, think of them as the intelligence officers showing the T cells what to attack. They actually hand over vesicles loaded with telomeres directly to the T cells,
Like they're gifting them extra life?
literally gifting them DNA protection. Lana calls this flow of vesicles telomere rivers. And this transfer completely prevents the T cells from becoming senescent. Senescent cells are those zombie cells that stop working and just sit there causing inflammation. Instead of becoming zombies, the T cells become stem-like memory cells. They stay young and ready to fight again.
But if our bodies do this naturally, why do we still age? Why does my immune system get demonstrably worse as I get older?
That is the big aha moment. Lana found that this transfer process isn't automatic at all. It requires a specific metabolic state. The T cells need to be performing fatty acid oxidation. They need to be burning fat for fuel.
And I'm guessing that stops happening as we age.
Precisely. As we age, our metabolism fundamentally shifts toward glycolysis, which is burning sugar. When that shift happens, the river dries up, the transfer stops, the T cells don't get the telomeres, they become senescent, and the whole system starts to fail.
So Lana basically said, what if I force the river to flow again?
Yes. His team used a small molecule they just called DO to disrupt a specific protein complex called SMAC. I won't get too bogged down in the biological acronyms here. But essentially, this molecule forces the cells back into fatty acid oxidation. It manually reopens the channel for the telomere transfer.
And the results in mice were, frankly, they were hard to believe.
They were stunning. The treated mice lived up to 60 months.
Context for the listener on that. How long does a mouse usually live?
A normal lab mouse lives about 30 months, maybe a tiny bit more if it's very lucky. Hitting 60 months is basically doubling the lifespan. It far, far exceeds what we've seen with other longevity interventions like caloric restriction or rapamycin.
Speaking of rapamycin, Lana threw a bit of shade there, didn't he?
He really did. He argues that rapamycin, which is kind of the darling of the anti-aging community right now, it doesn't actually rejuvenate the immune system. He says immune cells don't even have the target, mTOR, active in the way people think it is. He believes true rejuvenation has to come from restoring this actual telomere transfer mechanism.
But here's the part that really blew my mind. It's not just about the T cells living longer. The river flows out of the immune system, right?
This is the critical piece. The T cell takes about 50% of the telomeres for itself, but it packages the rest of them up and releases them back into the bloodstream. These youth vesicles travel through the blood to the rest of the body.
So the immune system is acting like a literal fountain of youth for the liver, the skin, the muscles.
Yes. They saw systemic rejuvenation in these mice. The mice had better posture, better fur, vastly more activity. It wasn't just that they didn't die, they genuinely stayed young. Lana's research suggests that our immune system isn't just a defense force. It's a maintenance crew that actively distributes genetic youth throughout the body as long as the metabolic conditions are right.
That is absolutely wild. So if we try to synthesize all this for you, on one hand, we have the pharma approach.
Right. Side A is control the damage. That's Eli Lilly and Novo Nordisk, using GLP-1s to dampen inflammation, manage glucose, and protect the organs from the fire of chronic disease. It's about keeping the house standing and functional for as long as possible.
And side B is the biology approach.
Reset the clock. That's Dr. Lana. It's finding the body's own mechanism for regeneration, this telomere sharing and unlocking it. It's not just shielding the house from fire, it's magically replacing the rotten wood with brand new timber.
What does this look like in the future? I mean, Andrew Adams mentioned one-and-done treatments.
Yeah, he talked about gene editing for cholesterol. Imagine getting one shot that fixes your cholesterol genetic risk forever. That's the ultimate convenience, fixing the roof while the sun is shining, to use his exact phrase.
And Lana envisions a world where we might not even need vaccines for every specific virus.
That's a fascinating concept. Instead of training the immune system for flu A or COVID variant X, you use this telomere transfer mechanism to keep the immune system in a permanent state of high alert readiness and youth. It's basically licensing the immune system to handle whatever comes its way.
It feels like we are moving from a passive role, just waiting to get sick, to an active role of managing our cellular biology.
We are decoding the instruction manual for maintenance that we didn't even know existed a decade ago.
So what does this all mean for you, the listener? I think the big takeaway here is that healthcare is completely changing. It's becoming about molecular maintenance.
Absolutely. And while we wait for telomere river injections to become a reality, which Lana is actively working on, by the way, it really reinforces the basics we already know, Lana mentioned that physical activity triggers fatty acid oxidation naturally. So just moving your body might literally be helping your immune system gift youth to your tissues right now.
That's a great connection. Exercise keeps the river flowing.
Exactly. It's the manual override for the metabolic switch.
I want to leave you with a final thought to mull over. We typically view aging as this slow, inevitable wear and tear, a car that just gets rusty over time. But Lana's research suggests something entirely different. It suggests that our bodies actually have a built-in mechanism to distribute youth, to physically hand over life-extending DNA through the blood.
We just lose the metabolic key to unlock it as we get older.
Right. We forget the password. So if we can turn that flow back on, whether through lifestyle now or molecules like DO in the future, are we just treating diseases? Or are we fundamentally changing what it means to be human?
That is the question, and I think the answer is a lot closer than we think.
Thanks for diving deep with us today. Keep those telomeres flowing, and we'll see you on the next one.